Greetings once again, functional game devers. This is your announcer, Ernest Pizarro, and you're about to watch another fine episode of The Joy of Functional Game Dev from your heart to the screen with your host, Ernest Pizarro. That's me, and it means that I still haven't managed to find anybody to fill in the announcer spot, so I'm going to do it myself until I do. If you'd like the job, please let me know. Now here's your host, Ernest Pizarro. Hello again, everybody. And, had a couple of hiccups this morning. Apparently some software installed itself that thinks that it wants to be the guy who records me playing this game. But it's not, so I beat it down and squashed it and configured it so that it doesn't automatically do what it does. There it is. I don't want to save the highlight. I really don't. It really, really wants to be the guy, doesn't it? But I don't want to. Dear Raptor. And exit. So, yeah, hey, the driver software really, really wants to do this. But alright, we'll see. We'll see if start over one more time, but whatever. When we last saw our hero, he was a blue smiley face right next to a gold $sign. He can't move. And so why in the world is he smiling? He's smiling because we're going to fix that this time. But in order to do that, in order to get there, we need to finish with wiring up the My Game events and get the stuff that we feed into they're going to feed into the constructor of My Game. And the other thing that we need to do is we have an update. So when we come in, and let's everything is all rammed together. Let's try a little bit to get some vertical spacing going on. Alright, so only three things that we do is we load content. And in load content we send the content manager into the texture loader and we grab out whatever our textures are going to be. This makes a big assumption that we're going to need textures. Fortunately that is a valid thing. But now I'm thinking about it, we'll deal with it. So we have update. Now we have game render, which happens between batch begin and batch batch end. I currently have it. You must always we must always clear it black, and I don't want to make that assumption. So actually, I want to pass that in. I want to pass the color. And we're going to go background color. And we're going to hopefully rely on type inference to realize that background color is color. And yay, chalk one up for type inference. Of course, now we're no longer, when building, we're no longer saying, hey dude, what's your color? Color.black. Of course, because I'm not Microsoft.framework. Oh, what's the name of the thing? My goodness, it is Microsoft.xna. Framework.graphics. I don't want to bring the whole Graphics.color. Or just that framework. Yay, alright. So I want to call the draw game, but the other thing that I need to be able to do is I need to be able to update. And the thing that the things that I need from update are, well, I need the delta that I'm being passed in, but other than that, so I'm going to do that's a game renderer. I'll call it game updater, and we're passing the delta in. Get a squiggly angry line because game updater doesn't exist, and say let update game delta will do some nothing. Of course, game updater hasn't. We need to define what game updater is, and it is pretty idiomatic to go, yeah, update then draw, update then draw. So I actually want to have game updater here, and will type inference know that it's a thing that takes game time, returns the unit. Yes. And for the moment, that's all good. And more importantly, we can now actually leave this code be. We can take this other stuff out of here. Make sure everything runs still. Build errors. No, I don't. Why would I want to do that? Takes 4 arguments, but here are given 3. Yes, that's true. So we've got my game.update game, and then my game.draw game. Here it is, super cool. And go. If it does the same thing, then we're cool. Alright, and we're cool. But so now I want to get this out of, I want this stuff away from my game. And really what I want is for my game to be off on its own. And actually, we're gonna actually make an entirely new project. It is a library, and it's going to be called The Joy of Functional GameDev .monogame, and that's where we're going to put anything that is that we can use. We'll leave a little assembly info there. Yoink, yoink. So we're going to put my game in here. I'm going to add a new item to say it's the joy of functional GameDev game, rather than my game. So we're gonna rename it as we do this. And if we need to modify things, that's all groovy. And it doesn't know about a bunch of things. So we're gonna we're gonna tell it about the stuff before we ever we tell it about the stuff before we really tell it about the stuff. So tell it about the stuff, and then we're going to manage our NuGet packages. And what do we have? Our installed ones. So I want this one. Let's install it. Install that one there. And let's install that one there. Hey, we get the readme text again. We will again not read it. Go us. Okay, so now we're happy there. So my game needs to get ripped out of here because it exists in the shared folder. But now Moneyface needs to add a reference. needs to know about that project so that it can make use of the thing that used to be in my game that is no longer there. So we're going to build it. It's going to say, no, I don't know what a mygame is. What is this mygame that you speak of? We don't have a mygame, so it's the joy of functional game dev dot that's game dot the joy of functional game dev game. And that should be good to go, and we've successfully pulled or refactored out the base game, and look at that, it knows nothing about the game. It is not coupled in the slightest to the content of the game. So all I have to do for future projects is I've got a place to start. We'll add some things to it as we go, but here's add this assembly and put it out there. At some point in the future, you can put it as part of a NuGet package. Here, bring this in, go. But before we get ahead of ourselves, let's make sure that it works. And there it is. All right. It does get dull after a while of seeing the same thing over and over and over again. But now, so board state. Board state is still there. And we're mostly going to I want to hide my random number generator at some point. And for now I'm not. For now I'm going to just kind of leave that. But when we use it just a little bit more, I'm going to do a similar thing. It's going to get factored out into its own module. But so back to board state. I believe, although I don't know for certain. So we're going to print screen it, and then we're going to paint.net. I'm going to paste that in. I believe, if I remember correctly, it's 800 by 600. The bounding rectangle is 800 by 480. Now, how in the world do I change that? Because really what I want is 1280 by 720. That's what I want. So we're going to look it up. Here, and I think it's under, is it under graphics device? It probably is. Let's take a look at my game. So, graphics device manager. I'm going to look up graphics device manager. So, I believe under my construction of graphics device manager is when I can, I have a constructor that I can pass. This is the size I want. That's ideal. Okay, let's look at the members. There's just one. Okay, so public fields. Okay. So the default back buffer height and the default back buffer width. So where do we set these things? So really it's just set those. Okay, we can do that, and we shall. But where indeed shall we do this? And I think that's in the game itself. And right here. Dot. And of course, what namespace are you in? Because we care about that. So xna.framework.game. Okay. Microsoft xna.framework.game dot device manager dot may not. It may just be, here's Graphics Device Manager, default, buffer width, we're just going to give it a 1280. Height, 720. What do you not like? Oh, you didn't like that you're right next to $8? This field is read-only. Okay. Maybe I should have read further. How do I set it? And that's time for a special segment, so we'll be right back. Today's F# operators of the day are the forward pipe operators. And here we are in our Sandbox app. We're going to take a look at today's operator of the day. Really, it's a set of 3 operators. And it's the forward pipe. If you've looked at any amount of F# code, you will see these all over the place. Less frequently, you will see these, and even less frequently, you will see these. And I'm going to show you why are these things here, and why are they so prevalent in F# code. Type location is an X and a Y. We're going to use a real example. Well, I'm going to go start with y equals start.y. This one. Let's make sure it's location. There we go. Gotta be careful with your space. Remember, kids. And it'll figure it out. Alright. We're also going to make a move south, where we add one instead. And, just to be complete, we're going to make a move east and a move west. And we'll go, those are the X's. And I've got it reversed. Not that it really matters. And so, what happens typically, we'll let my location equal x equals 0, y equals 0. So we're going to start the origin, and we're going to move north. So if I were to run this in interactive, I would have, there's no reason why we can't do that. Interactive. And it's y, and x equals 0, y equals -1. So, well, what's the difference between this and... Can't we just do that? Do I have to do anything special? And no, it would be exactly the same. So why don't we just do that? And the thing is what this operator allows us to do is allows us to say move north, then move east. We go again, and it's 1 minus 1. So it goes move north, so y minus 1, and then move east with its x plus 1. And if you have a whole bunch of things, very often this represents some sort of state through which we have a number of potential or a number of different operations or transformations. We just want to keep it going. And it's very prevalent in the F-sharp code to do this. Now, how about, so let's move north XY, where I take an X and a Y. And what I want to do here is I'm going to take X equals X, Y equals Y, and then I'm going to move north with it. And what does it not like? Now we'll go start X, start. Oh, you know what? How about we use an equal sign? How about we do that? Okay. So it's going to set up a thing. And so if I wanted to use this, just like so, I could then say, let my, we'll delete this one, we'll get rid of this one. Let my location equal move north XY 0, 0. And then I'll enter. And it would give me that. But now I'll do move north XY, and then I want to do another thing, and then I want some other stuff. I want to do that, and then I want to move east. And I can't do it the same way because, I mean, you can do this. Then take off your caps lock, move east. And that's fine, but this looks ugly. It's not, as they say, idiomatic. So what you do is you say 0, 0, and you double pipe forward. And what it does is it takes the tuple and throws it on the end, moves it east. And as you can see, +1, -1. So that takes a 2 tuple, moves it to the end, and then this parameter is over here, and then the second parameter is further on. So I leave it as an exercise to you as to what the 1, 2, 3 pipe forward means. So I always like to think of the forward pipe operator in the following way. I tend to think of forward pipe operators, as the and then operator, the leapfrog operator, or the just tack this on the end operator. And now we are back, looking on a quest to find out how do I change the size of the window. And how indeed do we? So, let us peruse the members, shall we? Graphics devices, full screen. I don't want to make it full screen necessarily. Okay, preferred. So I've got a preferred back buffer width and preferred back buffer height. So that's our guy. If you request a back buffer resolution that's not supported, you have to get the highest resolution. Okay, so alright. So we want to set. Well, let's see if it just works. So then, do I do that here on initialize? Let's graphics.preferred back buffer width. We'll just do this here just to, again, too much C sharping. This is what you get when you are doing that all during the week, and then on your times off, you're doing functional programming. You're going to have a little bit of a have a little bit of an imperative C-sharp accent to your F-sharp code. Well, it compiles. And let's see if it does it. It should be bigger. I don't know that it's any bigger. I don't think so. Do the print screen. Put it over in paint.net. Look at it. I don't think we did. 800 by 480. Okay. I think, well, you know, I think I saw something. I think I saw, Device Manager, let's go back. I think I saw an apply changes. So, apply, I think, let's give that a shot. It seems like a thing, graphics, apply changes. And so very exciting. Okay, that is bigger. That is definitely 1280. But hey, let's go in and prove it, shall we? Yes, sir. Magic Wand says 1280 by 720. Okay, we have accomplished the goal. 1280 by 720. Now, 1280 by 720, and at the moment, my my images are 32 by 32. And that's the truth. Is there any way to actually see it in this editor? I don't think there is. There might be. There's nice little hieroglyphics and things that don't tell me anything about anything. Nothing that tells me the properties. But it's 32 by 32. And the thing about, you know, back in the day, I used to deal with screen resolutions that were 640 by 480. And that divided evenly by 32. But now, bring up the calculator, we've got 720, divide that by 32, and we get 22.5. 22.5 is not one that makes a lot of sense. So I'm going to 22.5 tiles high. But with 720, I can go 36 and I'll get 20, or I can go 20 and I can get 36. And I think what I want to do is get 20. I think I want 20 by 20 tiles, or 20 by 20 images, and then be able to get 36 of them across. And then, so how does 1280 divided by 20? But of course, that's 20. That's not very big. Okay, so we're going to go 36. And then 1280. Of course, 1280 divided by 36 is going to be some weird number, but we're only going to go for 700. See what we're going to do here. It's going to take a square portion of the screen, which I can from here to, well, likely somewhere about here. Or we'll take it out the middle. And as a matter of fact, let's get a background for that and see how we want to do it. That's a perfect time to do these things. Let's go back to paint.net and let's make a new image that is 720 by 720. And we're going to go with magenta. It's not quite the magenta that I want. Actually, let's not kill our eyes with it. So let's go with a more, actually even less. Let's go 96, 96. So there's a nice deep magenta color. Save that off. We're going to go call it Playfield. And it's like, hey, are you sure? Does this image look good? It's a solid color. It doesn't know. So there's no idea. And we're gonna need paint.net later. We're gonna just minimize him. So time to add an existing item. Content star.png. I'm gonna add playfield and tell playfield to copy if newer. Great. We're going to put it in our texture thing, playfield, and at this point we're going to start going vertical here. Playfield, and it's called playfield. And now we got 3 of these. We're going to start being, how they say, idiomatic. And all that we really mean by idiomatic is, well, one day we'll have that as the something something concept of the day, or it's actually it's an F# concept of the day. Although idiomatic does exist for all languages, but anyway, we're making it easier to read. Of course, we're going to have other things, and we're going to have to fuss with it a lot. But that's the idea. That's one of the things. So, but now I have avatar dollar playfield, and I'm going to put on my draw game, and that'll be the first thing I do. And 720 by 720. That's my playfield. And that's going to be that. Well, that leaves a whole lot. That's a big thing of black over there. That is much too much to actually have. So I may not want to do this. I may want, because I can see if I cut that in half. Well, let's take a look at cutting it in half. Where's my calculator? I think I'll leave that up to, so 1280 minus 720 is 560. That's almost as wide as the thing. So divide by 2, 280 plus 720, 1,000. What a beautiful number, 1,000. We're going to use 1,000. We will minimize you, because I'm sure you'll be back. Well, but one of the things we forgot is I don't necessarily want, I don't want this hard-coded in my game, so we're going to make it will it let me do this or no? Width, height. What's it angry about? Probably not. Alright. Width. We'll call it back. Buffer width. Back buffer height. We're going to take that, throw that in there. Take that, throw that in there. And under program, we now say 1,000, 720. Well, not compile. It's not. One of the things I do get so used to in C# is it's compiling itself all the time. It's sort of Java-esque in that. Okay. And this one kind of does within the same module, but if it's in a different module, then you make your change. It's like, I don't know what you're talking about. So yeah, that's a much better field of black for status than before. So we're going to go with 1. So yes, we're not HD resolution. So if we have a video of just the gameplay, we're going to have the bars on the side, but that's okay. I much prefer prefer what this looks like. So, alright, got a play field in our purple. We've got how to pass the frame buffer width and height. Got this thing factored out, and I think we probably wanted to touch that for probably the rest of our time today at least. So, alright. Now, the next little bit is I'm rendering these things, and everything is sprite batch dot draw with my text, with this particular texture, and here's a rectangle and here's whatever. There's a similarity here that we don't. There's some similarities here that we don't necessarily want to have line of this, line of this, line of this. This is ugly. So what I want to do is I want a shortcut, and we're going to say we want to be able to pipe it. So let draw, call it draw texture, and we got a texture ID. We got an XY, and we do have a color. I don't think I care. It's always white until such time as we need it in a different color. In which case, I'll make a draw texture color in draw texture with color function and a sprite batch. And what I wanted to do is I wanted to return the sprite batch. Because what I really want to do is I want to say sprite batch draw texture playfield avatar and dollar. Avatar. Oh, and I don't have my XY, so we're going to go 0, 0. And that's going to be 0, 0. That one's going to be 32, 0. At least at the moment, at least till we get some new things. And what you're complaining that I have unit, because yes, I have returned sprite batch this whole time. And then I want to ignore you. We're going to take one instance of this, and our texture ID is going to get passed into here. I do need to have a let texture equal textures dot texture ID. I need textures. So I need to do that. I think actually what I need here I don't want to put the textures all everywhere, so I can actually double pipe it. Okay guys, we're going to double pipe it. Double pipe, and double pipe to ignore. Can I double pipe to ignore? Or can I just pipe to ignore? I think I just pipe to ignore. Alright. Textures ID. I may need to and textures sprite batch. Alright. So textures. So we're about ready for another segment. This should be working. So it likes type constraints. So let's let's give it some constraints and see if we can make it happy. I think the other ones can be inferred somewhat. Texture ID. Oh, and small I. All right. If we get this working, let's build you. We built. Do you work? If so, then we're having a good day. And we are having a good day. And so now, here's another little special segment, and I'll be back right after it. The F# language feature of the day is match. Okay, now we're going to talk a little bit about the match. And we're going to have a type here. We're going to have a type of porridge. Yeah, it's late at night. This is what happens. We got what kind of porridges we got. We got too hot. We got too cold. We got just right. Did I even spell porridge correctly? I have no idea. But in any case, let's what we want to do is we want to say let evaluate porridge temperature temp, and we're just for those at home. That's it. I know there's a worldwide audience here. I'm in the United States and I'm used to Fahrenheit, so we're gonna go with Fahrenheit. So we're gonna match temp with a value when V is greater than call it 140. There we go, too hot. V when V is less than 60, too cold. Almost 60. We'll call it 90. 90. And then everything else just right. And so, so as you can see, very, very powerful little expression here where we can match the temperature with these other things, with the when, but many times we use it for other things, like in a discriminative union, like let type my union. I don't want anything contrived. Call it type chair equals sofa of int, and we have a I've got some old relative, a Davenport, which is different than a sofa, is a particular of string, and a recliner of float. Why not? And we can say let evaluate chair, a chair equals match chair with sofa. So sofa 10 is just guess. So like sold or something. If it's sofa anything else, no way. If it's anything else, then not what I'm looking for. And so with discriminated unions, you can have matches of this particular thing with this particular value, and you can even have a V if it's greater than all, and you can combine it with whens. A lot of times not. It's typically here's a thing and something else, and then do something with it. But you can do all kinds of cool things with match, and it's highly useful, and I like to use it a lot. So. But the way that I like to think about match is like this. If the switch statement and regex had a baby, match would be it. And here we are, right back. Look, staring down a newly refactored draw game function and drawing textures, and because I would much rather do it this way than to have blah 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 blah. And well, we don't really know that it worked because we do know that that works. So let's see if it works for real with So you see, it doesn't work, but it was masked by the fact that we were still drawing it the other way. What I need, what I missed, texture.width, texture.height. And I meant to do that before, but now we've tested it and we're gonna work. Nope, and we're gonna go, that's right, because we're not taking XY into account, XY first, and you know what, we have no need of this, so okay. Have X, comma, Y. We don't need to bring it out here. Y. Some colors and some spaces. And now do we work? Spending a lot of time treading water. I'd really, really like to see the avatar move. So let's, okay, so we've got a board state, but we've got, they said, well, they're currently 32. So let's just, we have these things, let's leave it at 32. And we'll just make our board 22 by 22. 22 by 22. And so we've got a board state, we got a player state, we got a dollar state, or we got a dollar position. So let's make use of it and just get this done for now. But in draw game, what I really need to do is I need to load the board state. So let board state equal, and it's just load board state now. Load board state. So we've got a board state. It's of course called board state.load board state. We could put an open, but we're not going to yet. And our avatar, and this we will certainly clean this up. 32 times board state dot player dot, and give him the fist. And because it doesn't know things, there's that, and board player dot send. Right. See, it's exciting. We're gonna get there. The dollar. Okay. So let's get, let's see, do we have things in different spots? We do. Alright. Now we need to make a move. We don't have a lot of time left, but let's see what we can do. And during update game, what we want to do is we want to go back here, and I want to see the XNA framework. And I know there's an input class somewhere. And we'll just go monogame keyboard input. Let's let Google do it here. So where are we at? We're at keyboard.state. Now where exactly is keyboard? Well, keyboard. We'll look up keyboard.getState. Somebody somewhere is going to tell us. And tell us where are we. So we're in xna.framework.input, which I suspected. But let's, so have to bring that in. Open Microsoft.xna.framework.input. So here's what I want to do. So XNA. So we have the keyboard dot get state. And we'll say let keyboard equal keyboard dot get state. And yay for us. And well, now from there, keyboard. I won't press the keys on my keyboard. Keyboard.getState. Well, let's see. We've got keyboard.getState. It's undoubtedly going to have some little. No, it's not. No, it isn't. Monogame keyboard input. It's not going to have any example at all. You know, back in the day, things. Okay, so I get pressed keys. Get pressed keys. All the keys that are currently pressed. That's not necessarily what I want. But we'll okay. The update method here. Here's the new state. Keep an old state somewhere. There's a keyboard state. So we're going to need to, in order to respond to key presses, in our board state, we have to keyboard state xna.framework.input.keyboard state. So we want to do that. And sadly, keyboard state equal keyboard. Okay, this needs to have this happen. Goes micro framework.input keyboard. Now I don't know that this is going to actually work. And also we've done this twice. So that is enough for an open. We have a keyboard state. It's over here. Get state. I haven't done, see, this is going to happen before anything else, before anything's initialized, and I don't know. Well, looks like. Hey, dude, looks like for state, and we're going to also let update keyboard state with a keyboard state and a board state, because at some point I do need to say board state with keyboard state equals keyboard state, and it's going to return that. So, and I'll show you what we're going to do with that. So here in my game, I need to load board state. We're going to do an open board state here. Open board state. I'm going to look, am I using it anywhere else? I don't need that one. We're going to load the board state. And Squiggle says, hey, you're not, and we're going to pipe it into save board state. But what we're also going to do is we're going to update keyboard state. Keyboard state, and we're going to rename it. So we're pulling in the keyboard state. Ugh. Okay, we don't need you messing up our stuff. So save board state. Save board state is the new board state. What am I doing wrong? This is expected to have type board state to A. What am I missing? So update the keyboard state. State board state. So load board state takes nothing, returns a board state. Keyboard state takes a new keyboard state and an old keyboard state and then updates it. So I'm not seeing what I did wrong. Here has type unit. Over. Oh, I don't need that. See, and that's because. See, and that's because of that. So I thought, oh, that's there. That's in, and that's we don't use unit a lot, and that's okay. So what we do. So every time we update, we do we grab our new keyboard state. And we're going to load a board state. We're going to, and here we're going to do some other stuff. Well, and really, this one is this is where we're going to evaluate if is he moving. Is he moving in a particular direction? So we're going to say, going to move avatar, and we need the keyboard state to evaluate that. So one of the things that we're going to have to do is move avatar, and just so it compiles, we'll return the board state. But at this point, so now we got, I'm going to grab the old board. So let old board state, or old keyboard state equals board state dot keyboard state. At this point, this thing should be smart enough. So if old keyboard state dot is key down, keys dot up arrow, up. So well, is key up, and keyboard state is key down, keys up, then else So we're gonna let delta equal. We're gonna change his position. And we're gonna put, it's gonna be 0, 0. And we'll say let delta is that. That's a keyboard state. So we're gonna specify you are keyboard state. Just to make Mr. Compiler happy. So, and I believe it's still to go down. Y is down. So we got 1, 2, 3 other directions, but they need elifs. Down. I'm just roughing this in here because we can fix it in a little bit. And IntelliSense got confused because say, hey, you don't. So for down, it's a 1 here. If it is left, then it is a -1 here. 0 here, 1, go right, that's that way. And again, we're going to, with player equal, and board state, player, fist, board state dot player send plus the deltas there, so delta plus delta fist and plus delta send. Plus, don't do that. Alright, plus delta send. And operator precedence is unknown, so we put them in. Then we are almost out of time, but hopefully this should make it work, and in which case we can end episode 3 with, hey, I can move the guy around the screen. Tell your constructor, move avatar not defined. Moneyface monogame.fs. Let's build. Oh, we're successful, and everything seems to be happy. So if this works, now it's not doing any error checking as far as where can you be, but can I can move. Down doesn't work. Up, because I didn't do the up, did down. I can go up, I can go down, I can go up, I can go right. No. Okay. I can't grab it, but I can move my guy. And that's a good accomplishment for the day. We can move the guy. If we move him off screen, here he goes. But he comes back because he's just being rendered, and it's like I don't know where minus whatever is. Okay, cool. We're almost there. We just so next time we'll get ourselves back to him being able to grab those $signs and keeping a score. And so that's great. This is going really well. After 3 sessions of about 45 minutes long, 'cause that's really of this hour. That's about how much it is. So good job. There'll be the GitHub links down below of where the state of it is at this point. And thanks so much for watching. Be sure to like and subscribe. You've been watching a 4-tokened episode of The Joy of Functional Game Dev with Ernest Pizzera. Yeah, that's right, 4-tokened. It's a word. Look it up. If you like this video and like to see more like it, please like and subscribe. And you can always visit the Patreon page. Listen to the description below. This has been your announcer, Ernest Pizzera. Thank you.